Hello everyone, I hope you are doing well. So in this video, we're going to discuss Codeforce's Harbour.Space scholarship contest, which was rated for both Division 1 and Division 2. So I managed to solve the first 4 problems and now 20 minutes are remaining, but I'm too exhausted to solve problem E. So anyways, we're just going to discuss the first 4 problems and let us quickly start with the first problem. So the first problem says that we have been given 3 integers x, y and n. Now we want to form an array of size n. The size should be exactly n. The first element should be equals to x and the last element should be equals to y. Now we have to form it in such a way such that the whole array A is strictly increasing, and if we denote B of I as A of I plus 1 minus A of I, then this array B should be strictly decreasing. Right, so there are these two conditions, and during the contest I did not read the third condition. That is why I got one wrong attempt on pretest 1, but later when I realized this, then after I submitted the correct one. So now what we have to do is we have to form an array A such that it follows all these three conditions, and if there does not exist any array, we have to print -1. So let us see how we can solve it, but first let us copy this part. So this is the conditions that we have. Right, so if the size of the array is, let's say, 4, like this, then the first element has to be equals to A and the second element has to be equals to B. Right, now at this particular position I'll have to put some number smaller than B. Right, so let's say I put B minus 1 here. Right, now if I have B here, I have B minus 1 here, the difference between these two elements is 1. Right, so the next element that I should put here at this particular position should be smaller than B minus 1, and the difference between B minus 1 minus that element, let's say x, this difference should be greater than 1, because according to the third condition, if we form an array B with this particular values A of I plus 1 minus A of I, then this array B should be strictly decreasing. Right, so if the difference between these two is 1, right, so I would want that the difference between these two should be some value greater than 1. Right, so that is why I would want, let's say there is some number x, there should be two properties on x, that x is less than B minus 1 and B minus 1 minus x should be greater than 1. So from this particular equation you can see that x will have to be smaller than B minus 2. Right, so x, the value of x can be B minus 3 in this particular case, and the next value that we can have here is B minus 6. Right, so how am I calculating this value? You see, earlier I had B, then I calculated B minus 1. So the difference last time was 1. Now I would want to make a difference greater than 1. So that difference greater than 1 can be 2. So that is why I'm just going to take B minus 1 minus 2. Right, so that is why I got B minus 3. Now I want to make the difference greater than 3. So I would take B minus 3, that is the current element, minus 3, and that would lead to B minus 6. Now I can just keep filling all the elements in this particular manner till I reach this particular position, that is at the first index. Right, now at the end, after filling all the values, I just have to make sure that the array of 1 minus array of 0 is greater than array of 2 minus array of 1. Right, because the condition between these two values should be satisfied, because we are not using this particular method to fill those values. And there is one more thing, that the element at this particular position should obviously be greater than A. Right, so during the contest my implementation was a bit messy, but anyways, let me just show you my summation of what I did. So this is a very messy implementation of the problem, and you can write it in a much simpler manner. So what I did was, I took 3 integers A, B and C as input, and I created a vector answer of size C. Now I'm initializing my T with B and my IND with 1. So this IND is going to denote the change I need to make. Right, so initially I'm starting from position C minus 1 and I'm going to position greater than 0. So if my T becomes less than equals to A, that means I can directly print -1. So why am I doing this? I'm trying to fill all the position from index 1 to C minus 1. Right, so if at any of those positions my T becomes less than equals to A, that means I can just directly print -1 and return from here. Otherwise, I can set my answer of IST and I can decrement T by index. And then in the next step, I'm going to increment my index. So what will happen? Initially, 1 will get decremented from T. then 2 will get decremented from t, then 3 will get decremented from t, and so on. So the difference between the adjacent element becomes greater and greater by each iteration. Right. So at the end, I just put my answer of 0 as A, and I check this basic condition that answer of 1 minus answer of 0 is less than equals to answer of 2 minus answer of 1. Right. So if this is true, that means I cannot form my answer and I have to print minus 1. Otherwise, I can just print the whole answer vector and this would be the final solution. So I know that this implementation is a bit messy, but you can use the same idea to implement it in a different manner and that would be correct as well. So let us move on to the next problem. So this problem is swap and reverse, and this problem said that we have been given a string of n characters, right? All of them will be lowercase characters. Now what we can do is we can select any index I and we can swap the positions s of I and s of I plus 2. Now we have also been given a value k and we can select any subarray of size k and we can reverse that particular subarray. Now we have to find the lexicographically smallest string that we can form by performing any such number of operations. So this problem was very interesting to observe, and what you can do is, let's say you have a string something like this, right? So these will be positions, right? So let's say this is first position, second, third, fourth, fifth and sixth. So now if I can select index I and index I plus 2 and I can swap them, so you will see that I can select this one with this one and then this one, right? So all the odd indexes will be covered together and all the even indexes will be covered together, right? Like this. So for all the odd positions, if this is 1 and 3 and let's say we also have 5, right? So for all the odd positions, I can arrange the elements in any order. For example, if it is A, B and C, I want it to be CBA, so I can swap these two positions and that would be C and B, right? And then I can swap these two positions, that would be C and A, and then I can swap these two positions and that would be B and A, right? So if I am allowed to make any number of swaps, I can rearrange these elements in any order. The similar thing goes for the even elements. Now if I try to select some subarray of size k, right? So let's say this is 2 and this is 4. I select this particular subarray and I try to reverse it, right? So what happens if I reverse it? Let's say, let me just rewrite the elements. This is A, this is B, this is C and this is D. If I reverse all of the elements, then what will happen? This will be D, this will be C, this will be B and this will be A. And 1, 2, 3, 4, the indexes are as it is. So you see here the index of D was an even number, but here the index of D is an odd number. Similarly, for C it was an odd number here and now it is an even number here. So whenever I am taking a subarray of size k which is even and I am trying to reverse it, in that particular case the indexes will change their parity for each of those characters, right? So the most interesting part here is if I can reverse any number of times and if I can swap any number of times, then I can freely form any permutation I want in this particular string, right? Because for all the even and all the odd indexes I can rearrange them freely. And also I can swap the even and the odd indexes together, right? So for each element I can completely decide which place I want to put that element if the value of k is even, right? So I am free to decide any permutation. So whenever the value of k is even, my answer is just going to be the original string in a sorted manner. So I can take the string s and I can sort it and that will be my final answer if the value of k is even. But what happens if the value of k is odd? Right, so if the value of k is odd, I cannot perform any operation like this. I can still rearrange the elements among the odd positions and even positions separately, but I cannot interchange those positions, right? So odd cannot come to even and even cannot go to odd, right? So that is why what I'll do is I'll sort all the odd positions separately, I'll sort all the even positions separately and at the end write them all together. So let me show you the code and the implementation will be much clearer to you. So you see what I've done here is I've taken two integers n and m and I have taken a string input, right? So now if m is odd, then I'm just going to do something. Otherwise, I'm just going to sort the string s and I'm just going to print it, right? Now what I do, I create two vectors of characters. One is odd, one is even. And if the index is odd, I'm just pushing the character into the odd vector. Otherwise, I'm just pushing back the character into even vector. Now I'm just sorting both of the characters and I'm sorting it in reverse order. You will see now why am I doing this. So now I'm just traversing through all the indexes, and if the current index is odd, I'm just printing the back of the vector odd and I'm just popping the back element from there. Right. Similarly for even, I do the same. Now you see, if I would have sorted these two vectors in ascending order, then I would have had to maintain separate pointers to traverse through these vectors. But since I only need that particular value once, so I can sort them in reverse order and I can start picking elements from the back, right? So this pop back is an O of 1 operation, but pop front is not an O of 1 operation. That is why we generally do it like this. I can directly print the back element and I can pop the last element from the back. So this is how you can print all the characters present at odd indexes and even indexes separately, and that would be your final answer. So now let us have a look at the next problem. So this problem was divisor chain. Now again, this was an interesting problem. So this particular problem says that we have been given an integer x and our task is to reduce x into 1. Right. Now we can do one operation, and this operation looks something like this. We can select any divisor of x and change it to x minus d. Now there is a constraint on choosing the divisor, and that is we cannot choose the same value of d more than twice. Right, so we can take it 2 times, but we cannot take it more than twice. Now there is a very obvious reason why this condition is there. Otherwise you would always take 1 as a divisor and keep on decrementing the integer x by 1. Right, so that is not what they wanted, and they are also saying that it is always possible to do it with at most 1000 operation, and they say that it can be proved that such a scheme exists. Right, so basically we want to do it under 1000 steps, and let us see how we can solve this problem. So we'll try to figure out the problem in somewhat a reverse order. So let's say, let me just create a random binary number. So let's say this is the number. It will be like this, right? So this is a number that I want. This is the value of x, let's say. Now I want to perform some operations on this number to make it equals to 1, right? But let us try the opposite. Let us try the exact opposite. Let me take 1 and make it 2 raised to the power 5 first. So why am I doing 2 raised to the power 5? Because 5 is the most significant bit in this particular number x, right? So let's say now I have 2 raised to the power 5, and 2 raised to the power 5 can be easily formed. Why? Because what is 2 raised to the power 5? It is 2 raised to the power 4 plus 2 raised to the power 4, right? So 2 raised to the power 4 will be a divisor of 2 raised to the power 5, and I can subtract it from 2 raised to the power 4. Now I can take 2 raised to the power 4, I can represent it like 2 raised to the power 3 plus 2 raised to the power 3. So 2 raised to the power 3 is a divisor of 2 raised to the power 4, and I can subtract it from 2 raised to the power 4 and write 2 raised to the power 3. Similarly, it can also be written as 2 raised to the power 2 plus 2 raised to the power 2, right? And then again I can subtract it from 2 raised to the power 3 and write 2 raised to the power 2. So now I know that 2 raised to the power 5 can definitely be formed with 1. So I believe that this part is very clear, that I can easily form 2 raised to the power 5 or any value 2 raised to the power y from 1, right? And the reverse is also possible. So let us just assume for any number we are just going to take the most significant bit, and let's say that most significant bit is y, and we would first try to form 2 raised to the power y. So in this case we already have 2 raised to the power 5 now, right? So how do we proceed from here? Now let me just add 2 raised to the power 3 to it, right? Why am I taking 2 raised to the power 3? Because 3 is the next set bit in this particular number, right? So this number is going to be 2 raised to the power 5 plus 2 raised to the power 3. Now you will observe that 2 raised to the power 3 is actually a divisor of this whole number, right? Let me just prove it for you. So I need to prove that 2 raised to the power 5 plus 2 raised to the power 3 mod 2 raised to the power 3 is equal to 0, right? I need to prove this. So I can write it like 2 raised to the power 5 mod 2 raised to the power 3 plus 2 raised to the power 3 mod 2 raised to the power 3 is equal to 0. So this is obviously 0 because they are the same number, and obviously 2 raised to the power 5 is divisible by 2 raised to the power 3. So that means 2 raised to the power 3 is a divisor of this whole number. So that means from this particular state, 2 raised to the power 5 plus 2 raised to the power 3, I can definitely form 2 raised to the power 5. Why? Because 2 raised to the power 3 is a divisor of 2 raised to the power 5, right? And now I can take that particular divisor and write it like this. So I'll be able to form 2 raised to the power 5, right? So that means now I have 2 raised to the power 5 plus 2 raised to the power 3. Now I also need this 2 raised to the power 2 because it is the next set bit, right? So let me just write it as 2 raised to the power 2. Now with the same logic that I used here, I can also confirm that 2 raised to the power 2 is a divisor of this whole number, right? Because these two numbers are same, it is going to give 0. 2 raised to the power 3 is obviously divisible by 2 raised to the power 2, and 2 raised to the power 5 is also divisible by 2 raised to the power 2, right? With this logic, I can say that from this particular value 2 raised to the power 5 plus 2 raised to the power 3 plus 2 raised to the power 2, I can form this particular value 2 raised to the power 5 plus 2 raised to the power 3. Why? Because 2 raised to the power 2 or 4 is a divisor of this whole number, and I can subtract 4 from here to get this particular value. And I can further extend my same logic, and with the help of, let's say I currently have 2 raised to the power 5 plus 2 raised to the power 3 plus 2 raised to the power 2, I can add 2 raised to the power 0 here, right? So again 2 raised to the power 0 is going to be a divisor of this whole number, and from this whole number I can get this number, right? So you see that I have essentially formed my original number that I got as x. Now I have formed 2 raised to the power 5 plus 2 raised to the power 3 plus 2 raised to the power 2 plus 2 raised to the power 0, and that is equals to x. I have been able to form x when I was starting from 1, right? So I can just reverse my logic and try to get my answer, right? So from this number you can form this number, and from this number you can obviously form this number, and from this 2 raised to the power 3 plus 2 raised to the power 5 you can get 2 raised to the power 5, and we have already discussed how from 2 raised to the power 5 we can get 1, right? You can get 1 from here by dividing each time by 2. So that would be the complete logic. It was just pure observation and intuition. There is nothing very special. There is no special algorithmic thing used here, but if you understand how binary number works in depth, then you will be able to solve this particular problem. Now let us see my final summation. So what I have done here is, let me show you. So I have taken an integer n as input, and I have initialized my answer vector with one value in it, right? Now I'm just calculating the frequency. So this frequency array is just going to store the bits or the number n in binary form. Now I'm just running a loop from 0 to 32, and I'm just setting this f of I if this ith bit is set in n. Now if f of I is true, I'm just updating my index with I. So index is going to store the location of my most significant bit. Now I'm just trying to achieve 2 raised to the power the most significant bit. So that is why, while answer of back is not equals to 1 left shift index, so index is the most significant bit, I'm just going to push back answer dot back into 2 in this particular answer vector. Now I can just decrement my index value to get to the next position. Now while index is greater than -1, I'm just going to enter inside this loop, and I'm trying to find the next set bit. So while index is greater than -1 and not f of index, that means f of index should be set bit. I'm just going to decrement my index. Once I know that my current bit is set, I again check if it is greater than -1. I'm just going to push back answer dot back plus 1 left shift index. Right, so that is the bit that I am adding to my answer value, and I have already explained you why this works and why you can always add it. Now I am just going to decrement my index to get the next position, and at the end I can just reverse the answer vector so that instead of going from 1 to the original number x, I'll be going from x to 1. Now I can just print the size of the answer vector and all the contents of the answer vector. So this would be the solution for the third problem. Now let us have a look at the fourth problem. So before starting, I just wanted to show you this. I got TLE on pretest 2, and let me show you my summation. So the only difference between my accepted code and this TLE code is this particular line. Let me show you. So this particular line where I am printing some value in the error stream, right? So I'm using CERR. So this line caused me TLE, and it is known to give TLE in many cases. So I highly recommend you, before ever submitting your code, just make sure that you have removed all the debugging statements from your code. Otherwise, you will just get a TLE like me in this particular contest. And I got a penalty of 50 points without any reason. So anyways, yeah, I just wanted to make sure that everyone keeps that particular thing in mind. So now what we have to do is, we have a matrix of n cross n, which is only consisting of zeros and ones. Right, so they have given a slightly complex statement, but I'll tell you what they're trying to say. And overall, we need to find the minimum number of operations required to turn all the elements in the matrix to zeros. Right, so let me just explain you this particular problem, and then we'll see how we can solve it. So I have not explained you with the problem statement, but I'm just going to explain you directly here. So let's say you have a matrix like this, right? Now if you change anything, let's say at this particular point, then all the cells in this particular order, right, these cells and these cells, right. So you see I'm trying to form a structure like a triangle, right. All the cells covered inside these two lines, right, all of these cells, they will get their bit inverted, right. So if I make a change here, I can flip this particular bit and all of these bits represented by this particular area will also get inverted, right. So this is what they're trying to say. Let me just take one more point. So let's say I choose something here, right. So all of these cells and all of these cells, right. So all of these cells will get their bit inverted along with this particular cell. Right. Now we want to make all of the cells equals to 0 and we have to find the minimum number of operations required to do that. Now let's say there is this cell which is set at this particular position. Is there any way for me to make this cell 0 other than touching it directly? Right. You will realize there is no other way, because all the cells that are getting affected automatically should also have some cell above it. Right. So if I invert this particular cell, all of the cells below it are going to get affected. Right. But there is no cell above this particular cell, so I have to flip it directly. There is no other way for me. Let's say I have flipped this particular cell and all the cells in this particular manner also gets flipped, right. Now similarly I will have other cells in this particular row as well. Let's say this one, I will have to flip this particular cell and all the cells in this particular manner will also get flipped. Now let's say I was able to make all of these zeros, right. So all of these cells are zeros now. Now there will be some cells in this particular row as well. Since I have already made all of the cells in the upper row equals to 0, I would not want to touch them, and if there is any one in this particular row now, I'll have to change it directly, right. I cannot depend on the upper rows because all of them are already 0. I'm not going to change them. So their only other option is for me is to make this particular cell 0, right. So this would be the strategy of flipping the cells. Now the problem is, how do we know which cell is 1 and which cell is 0 at the current state? Because each of these flipping operations that we are making are having an effect on the cells below it, right. So we will have to take care of this particular thing. What are all the cells which are getting affected and how many times are they getting affected? Because let's say if there was a cell which was originally equal to 1, so it was flipped because some other cell above it was flipped, right. So let's say it became 0. Now it again got flipped because of some other cell, so it will again become 1, right. So you see the number of times this particular cell gets flipped is important. So this is my task, to find how many times the cells of a particular row are getting flipped. So how do I maintain this particular information? Now I have discussed this technique multiple times in the past. I have discussed it in Codeforce's editorials as well as my Geeks for Geeks problem of the day editorials. So the problem we are trying to solve now is, I have some start and end points, right. Let's say each of the range is denoted by some start and end points. Now I have to tell at any index I what are the number of ranges that are passing through this particular index, right. So let me just demonstrate it with the help of a diagram what I am trying to say. So if I have an array like this, let's say I flip this particular cell, so it will have an effect like this. Let me just draw it. So it will have an effect on this particular range, then it will also have an effect at this particular range, then it will have an effect on this particular range, then again this will extend to the right and then like this and then like this, and eventually it is going to cover the whole array, right. So it will have an effect like this on the whole array. Now let's say I have some other cell here and I am also flipping it, right. So now I am flipping this particular cell and let us see how its effect will be carried on. So its effect will be like something like this, then this, and then in the next step it will be like this and then like this and so on, right. So you see we are getting some ranges in this particular operation, right. So each of the ranges has some start and some end point, right. So it has a start and end point here. The start and end points are like this respectively, right. So you see each of the ranges have some start and end point, and we are introducing multiple ranges over the course of solving this particular matrix, right. So I know that what are the ranges for my current row, then I can easily calculate how many ranges are passing through this particular point. So for example, if I talk about this particular point, you see there are two ranges that are actually passing through it. So if it was initially 1, the first range will make it 0 and the second range will make it again 1, right? And if there was a third range, it will become again equals to 0, right? So how do I calculate how many ranges are passing through it? I'll maintain a start and an end vector, and with the help of these two vectors, I'm just going to calculate how many ranges are going to pass through any index C, right? So let's say these are in one based indexing, right? So these will be in one based indexing, and let's say I'll also have two extra columns, right? So my start and end vectors are also going to have some two extra columns. Why is this so? Because the actual columns are going to end here, right? So I can denote some starting range here so that these columns will always be covered. Similarly, for the ending range, I can denote the last ending range at this particular position so that this whole range can be covered. Let's say this particular column is J, right? So for the next row, I'm going to start a range from J minus 1 as well as J plus 1. Right. Similarly, for this, I'm going to start a new range from J minus 1 and J plus 1. Now, when I reach this particular position, let's say I had to flip this particular index, right? Now, what I'll do, I'll again start a range. Let's say this is J. So I'll start a range from J minus 1 and J plus 1 for the next row. And also for this particular row, this range was starting at 3. For the next row, this range is going to start from 2. Right. So I'll also have to update this particular information that if a range is starting from 3 in the current row, it is going to start from 2 from the next row. Similarly, if a range is ending at 10 for the current row, it is going to end at 11 for the next row. Right. So you see at each row, I'm updating two kinds of information. The first information is that if I'm flipping a bit at the jth column, then a new range is going to start from J minus 1 and it is going to end at J plus 1. So this is the first information. If at my current row, a range is starting at, let's say, S, right? So for the next row, it is going to start at X, S minus 1. Similarly, if a range is ending at E, it is going to end at E plus 1 for the next row. So this way, I'll have start as well as end vectors for each of these rows. Right. Now, let's say for the current row, I have a start and the end vector. Then how do I actually calculate the number of flips made at any particular column for any row? So let me explain you how do we calculate this. Let's say for row 1, I have this start and the end vectors, and for row 1, I want to calculate for each column what are the number of flips made at that particular position. So let me just have a frequency array, and my frequency of 0 is going to be start of 0. Right. So I'm defining a base condition. Right. So what will be the number of ranges passing through the 0th index? It will be equal to the number of ranges starting at the 0th index. Now I'm just going to run a for loop. Let's say I, 1 and n. Right. Now my f of I is going to be the number of ranges in the I minus 1th index. Right. So I'm just copying all the ranges here. Now at my current index, some new ranges will also be added. And what will be those ranges? All the ranges that are starting at the current index are going to get added. And obviously some range would have also ended at the I minus 1th position. So I am just going to remove all those ranges. Right. This way I get the number of ranges I have at the ith position. Right. So you just have to calculate this particular array, and this is very easy. Let me just explain this part once again. First of all, I set my base condition as that the number of ranges passing through the 0th index are equals to the number of ranges starting at the 0th index. Now for every other index, what I am going to do, I am just assuming that the number of ranges at I will be equals to the number of ranges at I minus 1. Right. After it, I realize that there must be some new ranges that will start at the ith position. So I add them. Now, there might also be a case that some ranges are ending at the I minus 1th position. So they will not be available for the ith position and so on. Right. So I subtract this particular value from f of I. So if I calculate this for all the indexes, I'll be able to get the exact number of ranges that are going to pass from my current index. And with the help of the number of ranges, I can calculate whether the current bit is set or not. Right. So if the current bit was initially not set, and the number of ranges that passed through it was odd, right? So it is going to be set. Why? Because let's say in one operation becomes 1 and in the other operation it again becomes 0, again 1, again 0. So you see in all the odd operations it is going to be 1. Similarly, if it was initially 0 and even number of operations happen, so it is going to be 0. right? So let me just also write it. If it was initially 1, an odd number of operations happen, it is going to be 1. If it was initially 0 and even number of operations happen, it is going to be 1, right? So now I can write a formula to find out whether the current cell will have 0 or 1. What I'll do, let's say, and that formula is equals to, let's say I have a grid G, my G of ij, and if I take 1, so this is going to tell me whether it is 0 or 1 currently, and I can take its XOR with f of j and 1. So what I am doing is, this is the original value that was present here. This will give me whether it is 0 or 1. So I don't actually have to take this particular AND. It will always be 0 or 1 only, right? Now I can take its XOR with f of j and 1. So you see what was happening. If one was 0, the other was 1, the answer was 1. If one was 0, the other was 0, the answer was 0, right? So it is exactly similar to the XOR operation. That is why I have applied XOR here, right? So I can take G of ij XOR f of j and 1, right? So f of j and 1 means whether it is odd or even. If they both are opposite, the answer is going to be 1, otherwise the answer is going to be 0. So now I know which of the bits are set and which of the bits I want to flip. And as soon as I decide that I want to flip the current bit, I also have to set j minus 1 and j plus 1 for the next row, right? So this was all about this particular problem. Now let me show you the code. So this is the final code that I submitted. So I've created a double dimensional vector G. So this is just to take the input, and I've created it of size n plus 2. I've already told you the reason why I've created of n plus 2. Now I just take input in the double dimensional vector, and I will initialize my answer with 0 and my start and end vectors with all values set to 0. Now I'm just traversing through each of the rows, and for each rows I'm initializing my frequency array of size n plus 2 with 0 values. Right, now my f of 0 is going to be equals to start of 0, and as explained, I am setting all the other values of f of I as f of I minus 1 plus start of I minus end of I minus 1. Right, now I also initialize my next start and next end vectors. So these are going to store the information for the next row. Right, now next start of 0 will be equals to start of 0, and next end of n plus 1 will be equals to end of n plus 1. Right, so this is just some base conditions. Now I'm just traversing through all the indexes from 1 to n. So 1 and n will be included, and I'm checking this particular condition. So actually you don't have to take AND here, because g of ij is anyways equals to 0 or 1. So you don't have to take AND 1 here. But with this frequency vector, you will have to take AND. Right. So if both of these values are opposite, that means our current bit will be set. And that is why I increment my answer. I increment my next start of j minus 1, and I also increment my next end of j plus 1. Right, so you will see next start and next end are going to store the information for the next row. Right, after all of this has been completed, what I am doing, I am just running a simple for loop, and if I plus 1 is less than n plus 2, that means this I plus 1 does not go out of bounds. In this particular case, I am setting next start of I plus is equals to start of I plus 1. So basically all the elements or all the ranges that were starting at I plus 1 are now going to start at index I. This is what I am trying to do. Similarly, if this I minus 1 index is within the range, in that particular case I am going to set next end of I plus is equals to end of I minus 1. So basically all the ranges that were ending at I minus 1 are now going to end at I for the next row. Right, now I update my start and end vectors as next start and next end, so that these start and end vectors are prepared for the next row. Right, so after I have done all of this, I can just print my answer variable, and that would be my final solution. So this was all about this particular problem. I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video, and don't forget to share your thoughts in the comments, because your engagement for this particular video really helps the YouTube algorithm to understand that this video is actually helpful for you, and it will be able to reach much more people like you who want to keep solving new problems. So I see a lot of people who watch these videos have not subscribed yet. In case you're one of them, then definitely consider subscribing. It's always free of cost, and you can always unsubscribe if you don't find the videos interesting later. So share this channel with your friends. Until the next video drops, keep coding, stay safe, bye bye.